Good afternoon, everybody. Thanks for joining us. So the lost art of software design. Over the past decade, maybe 2 decades, many teams have thrown away big design up front. This is mostly a good thing. However, many of these same teams have also thrown away things like architectural modeling, documentation, diagramming, and so on and so forth. These were all thrown away baby and bathwater style back in those early 2000s. It's worth noting here, of course, that the Agile Manifesto doesn't say don't do design, but we often read in between the lines and make assumptions about what is being said and what is not being said. And there's a great quote I like to use here by a friend of mine, Dave Thomas, and he says this: "Big design up front is dumb, doing no design up front is even dumber." And I love this quote. This really epitomizes what I've seen over the past 10 or 20 years in terms of how teams are approaching things like upfront design. It's worth noting here that many teams have tried to embrace things like evolutionary architecture and emergent design. So it's not as if we're throwing away design, we're just approaching design in a different way. But many people have misinterpreted this or done it poorly, of course. So I get to run around the world and run software architecture workshops, software architecture charters. And I did one yesterday here with the Learning Actors team. And I present the groups, the attendees, with some requirements. And this is how the exercise is phrased. Design a software solution for the financial risk system and draw one or more software architecture diagrams to describe your solution. Seems quite straightforward, but it's quite vague and quite open-ended, and there's lots of pitfalls. So we have 2 iterations. Iteration 1 is a limited amount of guidance, and we get a bunch of architecture diagrams that look like this. Yeah. The less we say about these, the better. So then we do some things, and we have a second iteration, and we get some nicer diagrams. So here is a system context diagram from C4, which is kind of pretty. I'll explain this later. And then we zoom into the red box, and we get some more smaller boxes. And that's really what the purpose of the workshop is about. It's about good communication and improving teams improve how they do diagramming and modeling. So what has this got to do with design? It looks like I'm just teaching people how to draw nice pictures. And that's true, but there's also quite a lot to unpack under the covers here. So let's do that. I'm going to talk about a couple of different topics here. The first of these is related to upfront design. So when I go in and visit many teams around the world, they ask me curious questions like this: are we allowed to do upfront design? Which I always find is kind of strange. It's like people are asking permission to do some design. I once walked into an organization and they said this to my face: "We don't do upfront design because we do extreme programming instead." And I said, "What? That makes no sense. Describe the way that you work." And they said this: "We go to our clients, we have some workshops, we do some analysis, we go back to our office and we start coding immediately." And I said, "How is this working out for you?" And they said, "Very poorly, that's why you're here." And it seemed that they were just rushing to write tons and tons of code and then getting stuck in that whole kind of technical debt refactoring cycle. And they just needed to maybe pause, reset, have some time around a whiteboard to collaborate, set a direction. I also get lots of people say that upfront design is not expected in Agile. This doesn't really make sense. There's nothing, again, in the Agile Manifesto that says you can't do design upfront. So where did this come from? If you look through some of the early literature around Agile and Agile ways of working, you'll see things like this. There is no big design up front. Agreed. Most of the design activity takes place on the fly and incrementally, starting with the simplest thing that could possibly work. We've seen this 1,000 times before. Martin Fowler, on his website, I've highlighted some of the text here at the bottom. Certainly, the most aggressive XPers are putting more and more energy into avoiding any upfront architectural design. So you can see where this don't do upfront design thing comes from. It's people reading between the lines in many of these statements here. It's worth noting that, again, the people behind the Agile Manifesto are not saying don't do upfront design, but they're not saying we should do design either. And again, it's very easy to make assumptions about what's not being said here. The other thing to bear in mind here is that many of those folks behind the Agile Manifesto have a ton of experience. Decades and decades of experience. Vastly more experience than many teams today, of course. So they're approaching a lot of this from a very different perspective, a very different angle. Something I've realized quite recently is this. Many of the people I'm now working with, I'm the oldest person in the room. These people have graduated in the past 10, 15 years. They've not seen the problems that Agile was trying to solve. They don't know about CRC and OOAD and rational unified process and all of those kind of older techniques out there. So they don't really understand what the Agile Manifesto was trying to solve, those problems behind it. Now, as an interesting thought experiment, I often wondered, what happens if you take some of those super experienced Agile people, super experienced in software development, you take them out of software development and put them into an area they are unfamiliar with. And then this happened a while back. So Kent Beck was between jobs or something, and he was writing a book. And he posted this upside down, I don't know why, but it's an upside down photo, and it shows an outline of the book he was writing at the time. And somebody replied, interesting that you've done this. Why not just write and refactor? And his response was quite interesting. He says, I've done circa 20,000 words, so I think this was a picture he'd put together after he'd written a bunch of content. So I've written lots and lots of words. To write a book, I need to see a whole in part to reduce my anxiety. That's exactly why I think teams should do some degree of upfront design. It's to reduce our anxiety. It's to explore the problem space, to explore the solution space. It's to give us a direction to make sure we're heading in the right way. So I kind of thought that was really interesting. And of course, upfront design is not about creating a perfect end state, a blueprint that we rigidly aim for. This is what we used to do 20 plus years ago, sure. We'd sit down for 6 months or 8 months or a year, draft up a whole bunch of diagrams and make sure we aimed at those diagrams at all times, irrespective of whether the world was changing. And this is why big design up front doesn't really work so well. You've got those very, very long feedback loops. And by the time we've delivered software, the world has moved on. Start with the simplest thing that could possibly work, the minimum viable product. I'm sure you've seen these sorts of cartoons many, many times before. There's also the other one, which is the Henrik Niebuhr cartoon. It starts with the skateboard, and then through iterations, we get magically somehow to a car. I prefer this version. This is from a blog post by Josh Kirievsky, Evolutionary Design, begin with a primitive whole. And again, it's imagine you want to build a great sounding guitar. How do you do it in iterations, in chunks? And we've seen this before. So there's nothing new here. So why am I showing it to you? But the thing we don't talk about is how do you get to version 1? How do you put a decent starting point in place? How do you put a decent version 1 in place that gives you the foundations to add features to in a nice, easy way in the future? When we're at the end of our 4-year journey, we can look back, and hindsight is a wonderful thing. On day 1 of our new product, we have no idea in which way we're going. And that's exactly what this is about. It's about putting a starting point in place. It's worth noting that the Agile Manifesto actually does talk about design and the importance of good design. And it says this, when you click through to page 2, which is the principles page. Continuous attention to technical excellence and good design enhances agility. So here you have the Agile Manifesto literally saying, yeah, good design's important. The other way to think about this is that a good architecture enables agility. And this makes sense, like from a gut feel perspective, this makes sense. If you've ever worked on one of those big, horrible ball of mud code bases, the spaghetti code bases, who's working on those today? No, please don't tell me. If you've ever worked on these horrible code bases, you change some code up here and some stuff down here breaks, and you don't know why, because it shouldn't be coupled, but it actually is coupled. On the flip side, if you've ever worked on a nice, well-decomposed software stack, highly modular, whether it's a modular monolith or a set of services running around a network, you have those nice hard boundaries. You change some code inside those boundaries. That's your volatility boundary. And you don't get that horrible blast effect or ripple effect into the rest of the code base. So for me, a good architecture is one that is well structured. It has a high degree of modularity. I think that's ultimately what we're trying to do here as software developers, designers, and architects. And I think we're trying to do enough upfront design to put that starting point, to put that direction in place. This is essentially technical leadership. When people talk about providing technical leadership to a team of developers, this is essentially what it means. It's about putting that direction in place for the team. And this is important for all teams of all shapes and all sizes, completely irrespective of what it is you're building. As a one-person team, I need a little bit of technical leadership. As a 100-person team, you need tons more. The principle's still the same though, of course. So that's a little piece about upfront design. We're going to come back to this in a second. I want to switch topic to my favorite topic, of course, for those of you who know me, incomprehensible software architecture diagrams. Who uses UML here? That's not a large number of people. UML usage is low. Whenever I poll audiences, it's 10%, maybe 20% in some countries like Germany, for example. They just have a different way of doing software engineering. I think that's a good thing. Don't hold it against them. It's also, it seems to vary different towns. So if you go to the Netherlands, Amsterdam might be like 1 out of 10, and Eindhoven might be 2 out of 10, just because there's more hardware, firmware, software type stuff going on there. But UML usage today is quite low. Why is it quite low? Someone said this to my face on a workshop. If you use UML here, you'll be seen as old. I was the oldest person in the room. Someone else pointed out, oh yes, and old-fashioned as well. So there's something about UML here that seems old-fashioned. Maybe it's the look and feel of the diagrams from Rational Rose all those years ago. A lot of people tell me UML is too detailed. UML is 800 pages of specification, tons of stuff in there. It's a language. You don't need to use the entirety of the language, but I will grant you there is something about UML that drags you into that detail. Imagine you are drawing a class diagram and you want to model a relationship between two classes. Do you use the black diamond or the white diamond? No one knows what those mean, so you go look it up on Wikipedia and it's composition versus aggregation. Nobody knows what those mean either, so then you go to another page on Wikipedia and you get a whole silly example of, if you have a car and it has 4 wheels, if you destroy the car, are the wheels destroyed? Like, I don't know. It's like, turns into a philosophical discussion now. And all you want to do is draw a single line between 2 boxes on a diagram. So there is something about UML, people want to get it perfect, they want to get it right. A lot of people say that it's a very elaborate waste of time. I'm not sure I agree completely with this, but there is maybe some degree of truth in here somewhere. So this begs the question, what's the option? What's the alternative? Just use whiteboard. Yay. The problem is, I run workshops all around the world. I've done hundreds in like 40 countries, and we do use whiteboards and pieces of paper. And this happened yesterday. We get all of these crazy sorts of diagrams that literally don't make any sense. So I guess it's at this point I should justify why I'm saying bad things about these diagrams. So what is wrong with these diagrams? So during the workshop, what we do is we get groups to swap their diagrams between groups, which is a horrible thing to do, and I apologize for anybody who came along to my workshop yesterday. It's a real eye-opener. And I asked them in the longer version of the workshop to basically have a look at the diagrams. Do you think they work? Do you think they satisfy the architectural requirements, the drivers? And if you were the bank in this case study, would you buy any of these solutions? And people walk around the room and they look at the diagrams, scratching their chin and go, yeah, we can't ask those questions, I'm afraid. And it turns out it's impossible to answer these questions because you can't see the solution. And if you can't see the solution, you can't evaluate and review and challenge the solution. So all of the diagrams are just visual noise, and the solution's kind of in there somewhere trying to get out. Lots of people tell me that, well, the value's in the conversation. So forget the artifacts, the value's in the conversation, and there's definitely some truth around that. So we have a collaborative session around a whiteboard. We sketch out a bunch of boxes and arrows on a diagram. We have some meaningful conversation as a group. We finish our conversation, we erase the whiteboard, and we all go on our separate paths. And then a week later, we need to have the same conversation, so we redraw a different version of the same diagram, and it's just wasteful, it's just ineffective. The other thing I've noticed over the years is this whole value is in the conversation thing only works if you can have the same conversation. And I've seen people looking at a box on an architecture diagram during my workshops, and one person thinks that box is a module in a monolith, and someone else thinks it's a microservice. And they've not had that discussion about what that box actually represents in terms of abstraction. So they're completely talking cross-purpose. So the question I want to really answer during this session is this one. How much upfront design should we do? It's worth pointing out here that when we're doing upfront design, we're not trying to decide everything. We're not trying to make every decision. So that begs the question, what sort of things are we trying to decide? I'd like to go back to Grady Booch's definition of architecture here. Architecture represents the significant decisions where significance is measured by cost of change. This is a really fabulous, short, snappy quote that I like to use to think about what's architectural nature and what's not. So things that meet this criteria from my perspective are your choice of programming language. If you have agreed to build a Java app, a week goes by, you have a week's worth of Java code. You can't just open that in an IDE, right-click, turn it into Ruby. So the choice of language is, it turns out it's hard to change later. It's an architectural decision. It impacts what you can and can't do later, of course. The libraries and the frameworks that become embedded in your code base, those things are hard to change later. Sure, we could write layers of abstraction around those libraries and frameworks. We could use ports and adapters or hexagonal architectures. That's another architecture decision. The structure of the code base is now significant. We've decided upon a structure. That structure is now hard to change. Anything around data, data storage, data reading, writing, querying, indexing tends to be significant and hard to change later. So for me, those are the sorts of things I put into the architecture category. Stuff like white space versus tabs, I literally don't care about. Right, have all those battles in your offices, write some tooling to fix it one way or the other. For me, it's the other stuff. You'll notice monolith versus microservices is also there. So the overall decomposition strategy you've decided to use. Because I've seen lots of teams jump from monoliths to microservices. And they've realized, yeah, it's hard. And now I'm seeing lots of teams going back the other way because they've realized it's hard and it's really expensive and they're not good at automated provisioning and observability and distributed tracing and all of those other complicated things. So again, it's something that you need to take into account. Again, Martin Fowler, to the rescue. He said this a long time ago. He said, I think there is a role for a broad starting point architecture. Such things as stating early on how to layer the application. So again, this is talking about your significant structural decisions, how you're going to do decomposition and modularity, how you interact with the database if you need one. So again, anything about data storage, etc., and what approach to use to handle the web server. So picture the scene. You're at work, you've been asked to design some new software, or you've been asked to make a change to an existing piece of software. You're drawing some diagrams. The questions you need to answer from those diagrams are essentially these. Do the diagrams reflect what we think we are going to build? And is it going to work? That's it. If I can successfully and confidently answer these two questions, I think we're in a good spot. And that's why just use a whiteboard, the values in the conversation doesn't necessarily work. Because, as I said, it's very easy to have the wrong conversations because we've not agreed upon abstractions and terminology and notation and all of those other things that affect the discussions that we're having. And that's why I think teams need a ubiquitous language to communicate effectively. What I find funny is we've spent the last 10 years thinking about domain-driven design and creating a ubiquitous language so that people in the business area can talk to developers, and when we say customer, we all know what that thing means. We've forgotten how to create a ubiquitous language for us as developers and architects to describe the things that exist in our software systems in terms of architectural building blocks. UML does solve many of these issues, allegedly, but perhaps it doesn't. You know, UML gives you a set of abstractions on one side and a set of boxes and arrows on the other side. But people don't want to use UML, they abuse UML. It's just hard. So I like to say this. I think a common set of abstractions is potentially much more useful than a common notation. I would love to be able to draw a thing on a diagram and everybody knows exactly what that thing means. So we have a common visual language for describing architecture. But I don't think we're there yet because we don't really truly understand what the abstractions are that we want to model, want to diagram. So that's why I say this, a common set of abstractions is more important than a common notation. There's a really good example of this in the real world, and it's a map. If you take two maps of Athens and put them side by side, they'll likely show the same things. All the tourist spots, the Acropolis, the shopping street, all of the old ruins and things, and metro stations and bus routes. The two maps are going to show the same things, but they might look different. Different color codings, different icons, different symbols, different shadings, and so on. How do we decipher a map? Well, there's a key or a legend in the corner, and it says when you see this symbol, it means X. So a real-world map is a really, really nice example of a well-known set of abstractions with a varying or variable notation. A real-world map, therefore, is a self-describing diagram. And that's a really, really powerful concept. So this begs the question, well, what are these abstractions that we potentially want to model? So I think about 4 of them. The biggest of these abstractions is what I call a software system. A software system typically has a team boundary associated with it. It's typically a bunch of code that's being released at the same time. So it's something that we're building as a team. We can see the internal implementation details of, we have responsibility for. That's what I mean by a software system. If we look inside these things, I'm going to say they are made up of 1 or more containers. This has nothing to do with Docker. Forget Docker. I got the name first, irrelevant as that might be. By container, I mean an application or a data store. So the software systems we build are made up of applications and data stores. Single-page apps, React, Angular running a browser, server-side apps, ASP.NET, MVC, Spring Boot, Spring MVC, Ruby on Rails, PHP, Python, etc., running on server. In terms of data stores, this is a relational database schema, bunch of documents in a document store, Amazon S3 bucket, something on blob storage in Azure, folder on a file share, etc. Zoom in, look inside the application containers, and they are made up of components. So I want to use the word component here to mean this: a grouping of related functionality, hopefully with a nice, clean, well-defined interface, running inside a container. So in this set of abstractions, the components are not individually runnable, deployable things. It's the container that's the deployable, runnable thing. And the components we build are basically made up of code-level elements. So if you are building a Java component, it's made up of Java classes, enums, interfaces. And the same is true of many other languages and so on. So that's it. It's a quite straightforward set of hierarchical abstractions. The software system is made up of 1 or more containers. Containers contain components, that's where the naming comes from, and components are built from code. Once you have abstractions in mind, you can then draw a bunch of diagrams, and this is where my C4 model for visualizing software architecture comes from. The C4 model is named after not the abstractions, it's named after the diagram types: context, containers, components, and code. And it's 4 levels of diagrams that essentially map onto those abstractions, and therefore allow you to tell different stories to different audiences. And again, the concept here is diagrams as maps. So you have different levels of zoom that allow you to see different levels of detail, from the very, very zoomed out 30,000 foot view, where Jersey in this case is a tiny, tiny dot because it's tiny, through to dropping into Google Street View, which is a one-to-one mapping with the real world when the photos were taken. So again, allowing us to tell different stories to different audiences. The high-level diagrams are quite technology agnostic. They're quite light on technology choices. So they're good for all manner of different people, both technical and non-technical. And as you zoom in and get deeper into that hierarchy of abstractions, it's much more technical in nature. The C4 model is notation independent. So although I did just say all those things about UML, you could actually use UML as your notation if you want to. C4 is essentially a set of abstractions and a set of diagram types. You can use UML profiles and extension mechanisms like stereotypes to plug in UML as your C4 diagram notation. Nobody does that, but you could if you want to. So the reason I put lots of emphasis on diagrams, to come back to this topic, is that I think diagrams are a fantastic visual checklist for making design decisions. So what do I mean by this? in order to draw a C4 system context diagram, you have to answer these questions. What is the scope of the software system we are building, designing, describing? So what features sit inside our software system boundary? What features sit outside our system boundary? Who is using it? So who are our roles, actors, personas, real people, and so on? And what types of things are they doing with our software? And what are the system-to-system integration points that we need to support and provide? Answer those questions, and you can draft up something like a context diagram. So this is an example context diagram from one of my workshops. The red box in the middle is the financial risk system that the team was designing here. They've correctly identified a couple of user types at the top, and they've also correctly identified a bunch of system-to-system dependencies that are part of the environment in which this case study sits. There's a bunch of notational tips here. It's got lots of text. It's nice. We've got a diagram key. So hopefully this is a nice readable diagram to most audiences. It's worth noting that this is a great analysis tool as well. So when you have those meetings with people for the first time, you can grab a whiteboard marker and draft up this diagram in those meetings. So this is the system we're building. This is the set of features you want. These are the systems around it. So it's a great way to explore the problem space. If we do the Google Maps pinch to zoom thing now into that red box, we drop down to level 2 of the C4 model hierarchy. It's a container diagram. It's showing us applications and data stores. In order to draw this diagram, it's a different set of questions. So what are the major technology building blocks in terms of applications and data stores? What are their responsibilities? And how do they communicate at runtime? So what protocols are we using, etc. Answer those questions, and we can draft up something like a container diagram. So now we zoomed into that red box. We still have the people and the systems around the outside boundary of the red box, and we can see the applications and the data stores inside that financial risk system boundary. So again, this is a really nice way to do a good level of design quite quickly. And the resulting diagrams should now spark much better, more meaningful questions. The questions that people typically ask during the first iteration of my workshop are questions like that. Like, what does this mean? What are the colors? What are the lines, etc., etc.? This is just visual noise. We don't want to be asking these types of questions. The questions I want teams to be asking about the diagrams are much more focused around the design and the underlying solution. So maybe you have 2 Java apps and there's an arrow between them, but it's not labeled. The question you should be asking is, what is this arrow? What's the protocol between these apps? How are these apps talking? Is it a REST API call? Is it a message bus? What's the deal there? Or maybe scan your eyes over a diagram and there's a database symbol and it says MongoDB. And you're like, well, I get why you've used that, but we don't support Mongo in this organization, so please justify your decision. So now you can evaluate, review, and challenge the solutions because you can see the solutions. Although in my workshops, we do the C4 thing and then we have that second iteration where we redraw the diagrams. It turns out in that second iteration, it's not just a redrawing exercise. People are not taking their existing diagrams and making them nicer. They're having to have more design discussions. Why? Because especially at the container diagram level, in order to adequately draw a decent container diagram, you have to have some degree of technical details. In order to get to those technical details, you need to have some more design discussions about, oh, how will this work? How will we build this? And so on. And now we have a way to scale this information outside of our teams. This is one of the biggest problems I see organizations facing even today in 2024. They have lots of little silos and they don't have a good way to scale information across teams, onboard new staff, and so on and so forth. It's also worth pointing out that the diagrams should now provide meaningful feedback as well. So it's quite common because of the hype around things like AWS, serverless, and Lambda style architectures. I get a whole bunch of people designing like a Lambda, so Lambdas to DynamoDB, triggering other Lambdas, etc., etc. That's quite a complicated solution for this little case study. And people come up to me and they say, we're trying to draw our Lambda-based architecture and our diagram is getting really complicated. How can we make this easier? And my answer is go and change your architecture, change your design. You've chosen a complicated design, so therefore your diagram's reflecting that complexity. That's a good thing. It's a feedback loop, it's information, use it to your advantage. Going back to the two questions. So we're drawing some diagrams. Is that what we're going to build, and is it going to work? So the C4 diagrams here allow you to, with some degree of confidence, answer that first question, but they don't answer the second one. And this is where we need to bring things like concrete experiments into the mix. Scott Ambler said this a long time ago on his essay about agile architecture. Base your architecture on the requirements. So find the things that drive your architecture the most. Find the things that drive the architecture decisions you are making. High-level non-functionals, constraints of the environment, and so on and so forth. Travel light, so do just enough, be sufficient, be lightweight, and prove your architecture with concrete experiments. A concrete experiment is nothing more than proof of concept, prototype, spike, tracer. There's a million names for essentially the same thing. It's writing some code to prove a hypothesis, and therefore de-risk your implementation. It's a risk-driven approach. George Fairbanks has a great book on software architecture. It's called Just Enough Software Architecture, subtitle A Risk-Driven Approach. This is exactly what we used to do with things like the rational unified process. Now, I'm not saying we should go and use the rational unified process. It's a big, heavyweight process framework that we were supposed to customize, but nobody ever got that memo. But it was a risk-driven approach. It brought the risky stuff to the early stages of the implementation lifecycle. RUP essentially says this: identify and mitigate your highest priority risks. The problem with risks is they're very subjective, in the same way estimates are. What you don't want is me as the architect crafting up a big list of the risks that I think are relevant to this delivery, this project, this product. I want to seek everybody's input. That's one of the things we've learned about collaboration and different ways of working since the Agile Manifesto was created, of course. So I have a technique, you can find this online. It's called risk storming, and it's a visual and collaborative way to identify risk. And it goes like this. Step 1, draw some pictures. Right, we know how to do that. That's easy now. Step 2, get a bunch of people who might have some input into what you are designing or changing. Give them a bunch of sticky notes of different colors. Pink sticky notes for high priority risks, yellow for medium, green for low. And ask them to look at the solution, look at the change, and identify what they perceive to be risky. Technical risks, infrastructure risks, data breaches, security risks, resourcing risks, cost risks, timescale risks, anything. And you do the planning poker thing. You think of a risk, you write it down on a sticky note, and you keep it to yourself so you're not biasing other people's thoughts. You do that for a really short time box, like 5, 10, maybe 15 minutes maximum. And then you say, right, time's up, step 3, go and stick your sticky notes on the diagram. So if you identify a medium priority risk with the risk calculation component, you stick it on that risk calculation component. Then you do the planning poker thing. If a bunch of people identify the same risk with the same score, you're done, take them off, log it, move on. If multiple people identify the same risk with differing scores, one high, one low, have a conversation. Who's optimistic, who's pessimistic? If only one person identifies a risk and everybody else missed it, that's also interesting. Are they super pessimistic, or have we missed something based upon their experience? So you're trying to elicit and elaborate and identify as many risks as you can here. Use this information to push on into your concrete experiments. Use the high priority risks and use those as the basis for your concrete experiments. Threat modeling is another older technique that I'm seeing more and more teams adopting these days, especially things like Microsoft's Stride. And it turns out you can do threat modeling on top of the C4 diagrams as well. Context, containers, and the supplementary deployment diagram actually give you quite a nice basis to do threat modeling on top of. One of the questions I always get with the diagrams is, how do we show non-functional requirements on diagrams? You probably don't need to, just have some supplementary documentation. How do we show the decisions that we're making on the diagrams? Again, you probably shouldn't need to. From my perspective, the diagrams show you the outcome of the decision-making process. In terms of recording the decisions themselves, that's why we use things like architecture decision records. Who's using ADRs here, by the way? Just a quick poll. It's not a small number. I kind of often poll audiences about architecture decision records. They kind of hyped a number of years ago, but I actually don't see many teams using ADRs. I'd thoroughly recommend using ADRs, looking at ADRs. It's just a short, structured, typically one text file per decision that you can record in your GitHub repo or something. that allows you to, so when you make a decision about using a programming language, a technology, a library, monoliths versus microservices, some integration pattern, just write that stuff down because it's a fantastic source of historical documentation in the future. You can also look at the traceability between decisions. So maybe you decided something in the past and you're changing your mind to a new version of that framework in the future. So you can track these decisions over time. So yeah, I thoroughly recommend looking at ADRs. So we need to wrap up, and I need to answer that question I kind of outlined before. So how much upfront design should you do? Sometimes you know what you're doing and sometimes you don't. So if you are doing a technology refresh, if you are building a system because of new regulations or compliance needs, that's a much more well-known thing than a startup or a product company, where you might be pushing stuff out there, pivoting, experimenting, getting feedback. So that's the initial kind of, which way do we go here? The problem with asking that question, how much upfront design should we do, is you'll get answers like this. So this is actually someone's answer from Twitter when I asked this question a while back. I'm good with maybe a day for a 1-year effort. So 1 day of design for a year's worth of development. This might work for the person who gave me this answer. I doubt it's going to work for most of us in this room. So this whole how much upfront design should you do question is a completely stupid question to ask. So I'm not going to answer it. What I am going to do is I'm going to make the assumption that we are going to do some degree of upfront design. And of course, upfront design is iterative by nature. We're never going to get everything right first time around, and we're going to have to change direction. So let's make the assumption that upfront design is iterative, and we are going to do some. A better question becomes, how do you know when to stop? And for me, it's pretty straightforward. You just look at a set of goals. So do you understand the significant driving forces? Do you understand the significant forces that are driving the decisions you are making in terms of your high-level functional requirements, your high-level quality attributes, and the constraints of the environment around you? If you understand those things well enough, you're kind of done. Do you understand the context and the scope of what you're building? So in other words, can you confidently draw something like a system context diagram? If you can, you're good, you can move on. Do you understand the significant technology building blocks? So modularity and technology decisions. In other words, if you can draw a C4 container diagram, you can meet this goal. You can check that one off as well. Do you have a way to share your information, your designs with other people? Again, diagrams help you do that. Are you confident that your design satisfies those drivers? Have you done things like architecture dry runs? Have you done things like architecture evaluations? There's a whole bunch of techniques out there that we can use. And finally, have you identified the highest priority risks, and are you confident with those risks moving forward? So have you done concrete experiments if and where necessary on all of or parts of your architecture? For me, that's what I'm trying to do when I'm doing upfront design. How do you do this stuff? That's our toolbox. There's a ton of techniques in the industry that we can use as software developers, architects, and designers to get to this set of goals. You've got some newer things in here like impact mapping, event storming, event modeling, DDD, and so on and so forth. And you have some older things in here like CRC. So there's a whole bunch of useful techniques there, old and new, that we can use as teams. So what I'm trying to do here, just to be completely clear, is I'm trying to do some degree of upfront design to put a starting point in place, but we're not going to get it right first time round, and we are going to have to iterate, and we're going to have to pivot, and we are going to have to change direction. But let's not get stuck in that charge forward, refactor, lots of technical debt, charge forward in a different direction, refactor, lots more technical debt. Let's make sure that any architecture changes in direction are done for justified, valid reasons, not just because somebody went to a conference and saw microservices is the latest thing. All of these things I've talked about, I've noticed are applicable for two types of organizations. Organizations who are moving towards agility, who maybe have been stuck in the past, who are looking for lightweight approaches to doing design, and also people who've gone through this agile transformation and they've thrown all the things away, and now they have no structure, they have no documentation, they have no diagrams. So for me, this is a nice lightweight set of techniques that apply equally well to lots of different types of teams here. And really, that's my closing point. We need to adopt an agile mindset. a mindset of continuous improvement. Find a bunch of tools and practice and level of design that works for you, and adjust if necessary. Thank you very much. Enjoy the rest of the event. Thank you.
Do you have any questions before we go off to a half-an-hour coffee break? I think everybody wants coffee. Okay, Simon, are you here today, tomorrow, and the day after? So
I'm definitely here today.
You're today.
Yep.
Okay, so make sure you bring him today. Are you available for an interview?
I am.
Okay, follow me.